I have here a paper written by Daniel Archer, Stellar Metamorphosis from Neptune to Earth. Excellent paper, Daniel. I'm very, very glad you wrote this. It shows that you understand the theory, and it shows that, it's a real thing. This is the real deal. I printed out a little outline to talk. Connecting Neptune to Earth. Basically, 0 papers exist in mainstream that explain that Neptune's size, composition, and mass will become like Earth's size, composition, and mass. Papers like that don't exist in the mainstream. To them, they formed as is, and nothing changes. They're not evolutionary structures in the mainstream, but they actually are evolutionary structures. Check that out. Clearly, it's an evolutionary structure. And we've been finding objects that are in between the sizes of Neptune as well. Neptune and Earth as well. It is not exact, but very similar, and D. Archer writes that in this paper. Thus, it is one of a kind and outclasses establishment's protoplanetary disk, nebular hypothesis, and all their accepted accretion models. It outclasses all of them. And basically because they don't understand that planets, astrons, are evolving structures. They did not form as is. They started off really hot, big, and bright. Number 2, it is absolutely fantastic that there exist people who are publishing papers on this theory. It gives me great relief knowing there are people who can develop this idea outside of me. This isn't about me. This is a theory. It's separated from me. When I fucking kick the bucket with a lightning bolt or a fucking car accident, somebody else is going to be able to work on it. That's fantastic. I was stressing for many years that nobody was writing papers on it and developing it. Now that it is gaining even a tiny bit of steam, it will begin to show greater growth potential, especially with all the exoplanets, astrons, that are being found today. And yes, many thousands upon thousands of them are going to be discovered, especially when a telescope goes up. Fucking millions of them. Many, 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 many millions of them are going to be found. The 4 sizes are roundabout estimate and not set in stone. They are simply to prescribe numbers, but the numbers in of themselves, inside of something as complex as astron evolution, are always up for revision. Show here. Size. Of course, we can give them sizes and give them examples, but these are all up to 2 variations. Life host, they could be bigger, they could be smaller. It's not set in stone. It's always up for revision, but the numbers there help us out a little bit to classify them, for now at least, which is, good. He also says in this paper that every astron has a potential to become Earth-like. It's very true. Just like all acorns are not going to become trees, but have the potential to. I'm working on that via the Taylor threshold. I named it after Baz. The Taylor threshold. Basically, there's a threshold for life where the star evolves just slow enough to where it can form life. Like the life hosting objects are going to be up here, and then if it evolves too fast, it can't form life. These are the acorns that never become trees down in this area. Of course, you could probably make mathematical formulas for that, but it wouldn't really be complete because mathematics abstracts away meaning from physical reality, and it can lead into absurd ideas such as Big Bang and dark matter and that kind of stuff. With Daniel's paper here, he says he doesn't want to get into how, exactly how the water forms itself, but he does say that it's hydrogen connecting with oxygen early in the star's evolution. Luckily, I've written a paper on that. Stellar metamorphosis, the total heat released as a result of ocean water formation. I have the average bond enthalpies for these for a lot of elements, given they're at certain temperatures and pressures. And that's the amount of heat that's released from the 2 atoms connecting together, making diatomic molecules and such. But these are just bond enthalpies, meaning the amount of energy when you break the bond. It's measured in kilojoules per mole. And I don't know if you guys taken chemistry before, but mole is the measure of how many molecules are in a certain set, or how many. It's a set number of molecules, and then however many set of molecules that is per per its mass. I don't want to talk about that right now. I guess pick up a chemistry book and look it up. But all I'm saying is to combine the oxygen and the hydrogen, given Earth's water as it stands now, is a lot of energy released when you combine all that hydrogen with the oxygen together. And I did some quick calculations here. I don't want to go into it. Click on the paper, but basically it's 3.6 times 10 to the 25 joules of energy released, synthesizing all hydrogen gas with oxygen gas. Now this is not even ionized hydrogen, ionized oxygen, or even to get them to their diatomic state. This is already diatomic hydrogen, already diatomic hydrogen or oxygen, to make the water of Earth's oceans as they currently stand. And if you want to look up orders of magnitude energy on the Wikipedia page, I put a link there. The amount of energy formed as a result of oxygen combining with hydrogen would fit inside of one of their little spots on that orders of magnitude energy. But since I don't want to edit Wikipedia, because I don't know, you can probably do it if you want. You can add this in there. Say, hey, look, this is a good spot to give a specific order of magnitude with energy. But with this, it's a lot more, because the water that was on the Earth was a hell of a lot more water. I would say about, easily, as it currently stands right now, there's probably 1,000 times more water, 2,000 times more water, 5,000 times more water on Earth than there's water that currently stand right now, which means it's about 3 magnitudes more. So it would be 3.6 times 10 to the 28 joules of energy just from synthesizing diatomic hydrogen with diatomic oxygen. And of course I put that up here, and I do the calculations for it. It's basic thermochemistry, and thermochemistry meaning the heat released in chemical reactions. So there's that paper. But yeah, I think the future of this theory is going to rest heavily in staged thermochemical reactions and electrochemical reactions. They're staged, meaning first this has to happen, then this has to happen, then this has to happen, and this has to happen. And all down the line, it gets less and less energetic as it goes down the line, and the reactions become more and more stable, to where the reactions are a lot slower and they take more time and complexity. And then before you know it, the dissipative event, what a star is, eventually breeds a lot smaller dissipative events, and eventually you get life. So I mean, it's incredibly complex. I've oversimplified the hell out of that with that explanation. But one thing's for sure here, as Daniel says in this paper, Earth's history is richer and deeper than the currently accepted paradigm. And that is very, very important, because I don't think that astronomers really can comprehend what 10 billion years is. I don't think they can comprehend that length of time. I think they can write it down on paper, but they don't really fathom that. They don't really understand how long of a time that is. Alright, y'all. I think that sums it up. I'll link all 3 papers to the bottom of this page.